Greetings, math fans. All right, so now we're starting our Harper review unit, okay? And basically what we're doing is we're putting together all topics that are on the Harper test. Now, we've learned really a lot of these topics. Some of the topics we haven't learned yet, but they're going to be in the next couple days. You're going to see it, and you're allowed to have that purple note sheet and make sure you kind of write everything down. But a lot of topics you've seen already. So in fact, today you've seen a lot of the topics. We're going to expand on one of them, and but anyway, this is on the Harper test. So if you don't know it, make sure you know it. Make sure you understand it. Make sure you watch. If hopefully you're in class, if not, you're watching the video again to make sure you guys understand this stuff. But you guys have to know it. And remember, the Harper test is your final exam grade. Okay. So whatever you get on the Harper test, that goes into place of your final exam. So basically, the next 2 weeks are 20% of your entire semester grade, because that's what this Harper test is. It's your final exam grade. Okay, and it allows you to get into Math 101. Okay, to test out of the 80 class of Harper. Okay, so let's start out with first kind of problems. These are absolute value inequalities. All right, so absolute value inequalities. We've done these already. All right, so I have basically two kinds of problems. Let's do absolute value of x is less than 5, and then we have the absolute value of x is greater than 5. These are the two kinds of problems you're going to get. Now, if you guys remember, if it's a less than, this is a between problem. And that's only because this is a less than. But this is the easy one to grade. Remember, this is grade to or, so that's going to be an or problem. And if you guys remember, a between is always, looks like this, right? A between is always a barbell. So you might have an open dot or closed dot, depending on what it is. And then an or problem are always like ors. So they always go this way. Okay? That's what you need to remember. So what I just drew in blue, that's on a number line. And when you solve it, well, we'll do an example of each one. In fact, let's just actually do this one problem here. The first thing I'm going to do, and guys, this is always the case. So you should have this on your purple sheet for day 1. When it's between, it's always going to be this. You're going to write x, and see the way this inequality is pointing? You're going to point it that way for both sides, and then you're going to write negative 5 and positive 5. Okay? And then if I make a number line, it's going to be negative 5, positive 5, and you're going to have an open dot here, and that's the answer to that problem. It's between negative 5 and 5. Okay, but you got to look at this number, guys. You got to look at this number right here, and this number is a 5, and that's why you put it positive 5 and a negative 5. Make sure you put it in the right order, and then the inequality is always going to point the same as the other one. So it's going to point that way. That way you put the x in between, and you know, this is an easy one. You don't have to solve for it, but that's kind of the gist of how it looks. Then it's a barbell. Okay, the one greater than 5. So what you're going to do is, this is how you set it up. Ready? It's x. Again, this is always, always, always. X is less than negative 5, or x is greater than positive 5. So this is a positive here. Okay? And the answer then to this problem, oh, by the way, so here, let's just kind of show you a couple of things. It's negative of that number, and it's less than, and it's greater than positive of that number, which is just 5. Okay, and then you know it's going to be like oars on a boat. Okay, so if I would graph this, you're going to say negative 5 and 5, and then this is an open dot pointing this way and an open dot pointing this way, and that's your graph. Okay, pretty easy. So let's do, I want to do a couple of them that are, you know, have a little bit more than just one number here, and hopefully you guys are good to go. Okay, so if I give you guys absolute value of 2x plus 1 is less than, let's say, 7. And let me just do the exact same problem. Absolute value of 2x plus 1 is greater than 7. So you kind of see how both are. In fact, let's make this an equal to. Okay, just because then it's a solid dot. So remember, if it's less than, I'm going to tell you right away, this is a between problem. So this is a barbell. So this is going to be some graph that looks like that. This is a greater, so this is an or problem, and this is going to look like an or, a bunch of ors, or a set of ors. That's the way that's going to look. Okay, so let's set it up correctly. You're going to say, again, it's between, so you're going to say 2x plus 1. It's between, so point those inequalities that way. This is negative 7, and this is positive 7. Okay, and then I solve for that inside there, so I'm going to subtract 1 from all three sides. And again, if you need your calculator, it's great. That's going to be negative 8, less than or equal to 2x, less than or equal to 6. Okay, and then you're going to divide both sides by 2. You're solving for x in the middle there, so you're going to divide everything by 2. So you get negative 4, less than or equal to x, less than or equal to 3. Okay, so your graph looks like this, guys. I know it's a barbell. I know it is. So it's negative 4 and 3, and these are solid dots. And that's the answer. So you got two parts to it. This is the answer, and the graph is the answer. Okay? Now I'm going to show you, I'm going to bring this up now, and I need to show it in class too. There's something called interval notation. Okay, and basically you're going to see this on the Harper test, so I'm going to show it to you now so you make sure you know what you're doing. That when I write that x is between, when I say x is between negative 4 and 3, interval notation is basically this. Let me write it out. Let me just write the solution out. Negative 4 comma 3 in a bracket. So this means, math fans, this guy right here means it's between negative 4 and 3. Those brackets mean, the brackets mean this. So less than or equal to, and so it's between these. If it's an equal to, it's a bracket. Okay, if this was x is between like this, negative 4 and 3, that would be a parenthesis, negative 4 comma 3. Okay, it's something you kind of need to know. We haven't really talked about this. I'm going to start talking about it soon, so you start seeing it. But that means between negative 4 and 3. Okay, like I said, this top one right here, this is including the negative, or not including the negative 4 and the 3. That's why it's a, that's why it's this, just less than and less than. This one's less than or equal to, less than or equal to, and that's why this one gets the brackets. So it's between negative 4 and 3 with the brackets. The top one in purple is between negative 4 and 3, not including negative 4 and 3, so it gets a parenthesis. Okay? Probably confuse you a little bit, but I'm going to start talking about this every day, about those parentheses and the brackets. Okay, so let's actually, let's switch over to this guy right now. Okay, so we have our final answer, and it's a barbell. This one is a greater. So if you guys remember, how do we set it up? We just said 2x plus 1 is less than or equal to negative 7, or 2x plus 1 is greater than or equal to positive 7. Okay? That's the setup. You have to know that setup. Less than negative, greater than positive. And then you solve for each one of these. So I'm going to subtract 1. So 2x is less than or equal to negative 8. Divide by 2. X is less than or equal to negative 4. This one, subtract 1 from both sides. So 2x is greater than or equal to 6. Divide by 2. X is greater than or equal to 3. So it's an or in between. So that's the answer. It's between those two values. Okay? And then what you're going to do is, when you graph it, you know it's like an or. So you're going to say negative 4 here and 3 here, and these are solid dots. So less than that, less than or equal to that, and greater than or equal to that. And that's your answer. Okay, so again, your answer is this guy right here, and then the graph. Okay? So I guess I could do another example, but I just want to kind of go through it quickly. We've seen this already, so hopefully you guys are good to go. If you write down exactly what I did here, you will get the problem right. Okay? If you don't, you're not going to get it right. And there aren't a lot of problems on the Harper test, guys. Okay? I mean, we're talking, you guys need to, I'm looking at the Harper test right now, and basically there are not a lot of questions on there. Okay, there's like 20, it's a 2-day test, and each day has about 22 questions. Okay, so some of them are multiple choice, but some are actually fill-in. So one day, I'm just looking here, one day is 22 questions, another day is like 12 questions. Okay, so yeah, actually the total, I'm looking at the total. The total for both days is 22 questions. Okay, 5 of the questions are right out. 6 of the questions are right out. Okay, I lied. 8 of the questions are right out. Okay, so there's 4 each day. I'm sorry, I mean, I'm just looking at this right now as I'm talking. Okay, so the first day there are 4 right out questions, and then there's multiple choice. Okay, and there's 11 multiple choice. So that's what it is. It's 4 right out, 11 multiple choice. The next day, 4 right out, and 11 multiple choice. Okay, so we're good to go. That's what it is. So make sure you know what you're doing. All right, so that's the first kind of question, is absolute value inequality. I want to do one more of these because I want to make it a little bit tougher one. Okay, so let's give it a shot here. If I said absolute value of x plus 3, close absolute value, minus 4 is greater than or equal to, let's just say 10. Okay, so the first thing you're going to do is you're going to isolate that absolute value. If you guys remember that, you're going to add 4 to both sides. So you get absolute value of x plus 3 is greater than or equal to 14. Now, you're done with looking at least solving for the absolute value. It's grade 2, so this is an OR problem. So again, please know how to do this. It's x plus 3 is less than or equal to negative 14, or x plus 3 is greater than or equal to positive 14. You got to know that. It's less than negative and greater than positive. You have to know it. Okay? And I know it's an OR, so I know it's going to look like this on a number line. And because it's equal to, it's a solid dot. Okay, so I'm going to subtract 3 from both sides here. So I get x is less than or equal to negative 17. And I'm going to subtract 3 here. And I get x is greater than or equal to 11. So this is the answer, guys. And on a number line, you're going to say negative 17 and 11. And it's going to point like this. Okay? So that's it just for this guy. So we got 2 more kinds of problems here they want to talk about. So let us try this next kind of problem. The first set of problems is actually pretty easy. Okay, so if I give you guys the square root of 2x plus 1 is equal to, let's go with 3. If I want to solve for x, I'm going to square both sides. All right? And if I square a square root, it just cancels it out. So I just get 2x plus 1. If I square 3, I get 9. Please don't tell me plus or minus 9. That's only when you have x squared equals, let's say, 9, and you take the square root. Then you get x equals plus or minus 3. Otherwise, this is not that kind of problem. Okay, so you square it, you get 9. So again, this is really easy. I'm going to subtract 1. I get 2x equals 8, and divide by 2. So x is 4. That's the answer to that problem. Okay, let's do another one here. 3 plus the square root of 3x minus 4 is equal to let's just go with 11. Okay, so the first thing I'm going to do is I'm going to subtract 3. So I get the square root of 3x minus 4 equals 8. And I'm going to square both sides. So if I square both sides, I get 3x minus 4 equals 64. And then I solve. So I add 4 to both sides. So 3x equals 68, and then divide by 3. And this one you get a little bit nasty decimal. You get 22.67 or 22 2/3. Okay, so again, pretty easy to do this. Now this is the ones that's a little bit more challenging. Okay, so let's go ahead and do this guy. If I give you a problem like this, the square root of x plus 15 is equal to x plus 3. All right, so what I'm going to do is I'm going to square both sides because I want to get rid of that square root. Now please, when you're squaring x plus 3, please, please, please don't write x squared plus 9. It's a horrible mistake. Okay, you got to write it out twice, x plus 3, and then you got to FOIL it. Okay, so this one's easy. That one's just x plus 15. Right, the square root goes away. This one, when I FOIL it, I get x squared plus 3x plus 3x plus 9. Okay, then I'm going to subtract x and subtract 15 from both sides. I want to get everything to one side. Actually, before I even do that, if I combine this together, do you guys agree I get x squared plus 6x plus 9? And then I'm going to subtract, so let me just write this out here. X plus 15 equals x squared plus 6x plus 9. I just like this better. Now I'll subtract x and subtract 15. So you should get x squared plus 5x minus 6 equals 0. And then you do a factor box and you factor it, or however you factor it. I'm teaching you this way, factor boxes. I'm not even going to do it because you guys, there's so many different ways to factor. But if you factor this, this is what you get. You get x plus 6 and x minus 1 equals 0. So x equals negative 6 and x equals 1. Now those are your two answers for this problem, but you have to check these answers. There's a problem like this on the Harper test. You have to check your answers because both of these may not work. And what you're going to do is you're going to take those two answers and you're going to plug it back into the original problem. So I'm just going to cursor down here, but the original problem, so here, actually I'm just going to clear this. So we got x equals negative 6 and 1. Those are our possible answers. Okay, so x equals negative 6 and x equals 1. And our original problem was this. Square root of x plus 15 is equal to x plus 3. That's our very original problem. So I'm going to plug in the values into here to see if it works. So if I plug the negative 6 into here, I have the square root of negative 6 plus 15 equals negative 6 plus 3. And see if it works. The left side equals right side. So negative 6 plus 15 is 9. So square root of 9. And negative 6 plus 3 is negative 3. So square root of 9 is 3 is not equal to negative 3. So this is not a solution. 6 is out of there. Let's put the 1 in there. So it's going to be the square root of 1 plus 15 is equal to 1 plus 4. Okay, square root of 16 is 4. Oh, sorry, did I say, it should have been plus 3. Sorry. This is 1 plus 3. And then 1 plus 3 is 4. Woo! So this is good. That means 1 is our only answer for this problem. Okay? You've got to check it. They're going to be looking for that. They're going to be looking that you can square both sides and you know to FOIL it. And then they're going to be, what a couple of the points are, did you check your work and see if there's, we call this an extraneous solution. So this one didn't work. The negative 6 did not work and the 1 did work. You have to check it. Okay? If you forget, you're going to lose points. And you want to do that. Okay, so let's try another one here. Okay, if I do x plus 2 equals the square root of 5x plus 10. Okay, so the first thing I'm going to do is I'm going to square both sides. So if I FOIL this out, x plus 2, and if I square that, I get 5x plus 10. So then I get x squared plus 2x plus 4 equals 5x plus 10. So x squared plus 4x plus 4 equals 5x plus 10. Remember, you got to get everything to one side. So I'm going to subtract 5x and subtract 10. So I now get x squared minus x minus 6 equals 0. And again, however you factor this, factor box, slide and divide, whatever you do, you should get x, and you should get minus 3x plus 2 equals 0. So x comes out to be 3 and x comes out to be negative 2. And you take those problems and you plug it back into the original problem. So the original problem looked like this. X plus 2 is equal to the square root of 5x plus 10. So if I put a 3 in there, I get 3 plus 2, and then I put a 3 in there. 5 times 3 plus 10. So 3 plus 2 is 5. 15 plus 10 is 25. So 5 equals 5. So 3 is good. Okay, let's do it negative 2. So if I put a negative 2 in here, I get negative 2 plus 2 is equal to square root of 5 times negative 2 plus 10. So negative 2 plus 2 is 0, and 5 times negative 2 is negative 10 plus 10 is 0. Hey, all right. So 0 equals 0. So 2, or negative 2, is also an answer. Okay, a lot of times it's not. A lot of times only one works, maybe none work. In this case here, both of them work. But you have to check your answers. If you don't check your answers, you will lose points. Even if it doesn't work, you still have to show the work that you did that. Okay, I'm looking at the scoring sheet, and one says you have to check your answers. Okay, if you forget, you lose 1 point. Okay, so that's it, math fans. That's day 1, and this is going to give you basically what I just did now is going to give you credit for 3 problems. And I told you you have 22 multiple choice and 8. So there are 30 questions total on this test. All right, 30 questions, and we have just covered 3 of them. Okay, so that's it, math fans. Hopefully you guys are good to go with this. If you have any questions, you got to ask in class or watch the video again or whatever, but you need to know what's going on to do well in this Harper test. Okay, that's it, math fans. Have an outstanding day. Adios. Goodbye.